So my major is computer science, and when we were reading through the textbook and we came across supercomputers, I became really intrigued with them because they related directly to my major. So in this video, I wanted to really focus in on supercomputers and how they help weather forecast. Okay, so supercomputers are super different from your normal, average, everyday computer. One difference is they are a lot more powerful and they are quite large. In fact, some of them can be as big as a school bus, so that's pretty big. And they also process information a different way. So your average everyday computer uses serial processing. However, the supercomputer uses something called parallel processing, which allows it to do many things at once, and it can run different functions at the same time. So you may actually be familiar with supercomputers. One of the most famous supercomputers is IMB's Watson, and you may have seen that certain Jeopardy episode where they put Watson on and he was allowed to compete, and it was a really interesting episode, and if you have not seen it, I would highly recommend it. Um, and so supercomputers help in so many different fields. For example, medicine, I know that they're using supercomputers to find new research with cancer and different types of treatments, and it's also being used for security. They use it for facial recognition and things like that. And of course, what we're going to be discussing today, which is weather forecasting. So, supercomputers use numerical forecasting in order to forecast the weather. And numerical forecasting basically just means using math to predict the weather. And supercomputers have the capability to do 2 billion operations per second, which is kind of unbelievable. It's pretty dang crazy, but it's true. And so they take in a whole bunch of factors when predicting weather. For example, they take in air pressure, wind direction, the Earth's rotation, solar radiation, and so much more. And all of those factors go in when they're seeking about to predict the weather. And since all of those factors are being factored in, that leads to a lot more accuracy. So this leads the question, how does the supercomputer predict weather? Well, it takes in observations and then turns those observations into numbers. It takes observations from weather balloons, satellites, buoys, radars, and even sensors on commercial aircrafts and ships. So it takes all of these observations and then it turns them into numbers, and then these numbers are then plugged into algorithms, and then they're put onto like a model grid, and then they can run simulations out using algorithms, and they kind of have like a little mini atmosphere to work with, and they can kind of see how the weather will play out. So supercomputers use climate projections to be able to predict weather. And these climate resolution models can be in high resolution, which means that there is a lot better accuracy, and they can also really clearly see the terrain instead of just altitudes on a grid, which is a lot more helpful. And you need to be able to have 100 terabytes, which is also known as 100,000 gigabytes of data in order to do this. So there's a pretty phenomenal amount of storage that needs to go into doing this. And then they can use this to predict weather phenomena such as hurricanes and tornadoes and snowstorms and etc., etc. And one interesting thing is it can also reveal the effects of climate change. And it can also predict how climate change is going to evolve in the future. So I wanted to share this little video with you, and I don't know if you can see, but this video is actually a video of carbon dioxide, and the red is where it's most concentrated and the blue is where it's least concentrated, and this is one example of how they can kind of see how global warming will progress in the future, because as we know, global warming and carbon dioxide are directly linked. So supercomputers are really amazing, and they do an amazing job of predicting the weather, but they are not 100% accurate. So it can be hard for scientists to know when to warn the community. For example, if they're being overly cautious, then and they're releasing warnings that end up being false a lot, the public is probably not going to take alarm when there's actually an emergency. So there's definitely a fine line that needs to be addressed of when they should warn the public and when the chances aren't so great and they should refrain from warning the public. But if used correctly, supercomputers are invaluable and they have the potential to save lives. Alright, and then here is my bibliography and all the sources that I used. And if you're interested, and I will also leave a link to all the articles I used as well as the video down below in the description. And that's all. Have a wonderful day.